They'll figure out what to do, right? And probably the slide advancer may work.
This will be fun. Okay.
Okay, today's presentation is by John Fogel.
Okay. So I'm going to start on an update with some of the cat selenide quantum dots and some of the ligands for hole extraction that we've been working on. So what I'm going to show today is just kind of a partial model list for the ones that have completely finished converging. So this very top left edge here is just cat selenide 3333, and it happens to have 9 amine ligands on there. And so that was an optimized model I got from Levi, and so that's kind of a base model to see once what the electronic structure of just the quantum dot itself is with these 9 amine ligands to give some type of surface passivation or solvent effect, so there's not tons of reaction sites all over this quantum dot surface. And so the other two that I'm going to show today are what are called a BA PTC. So more or less the main difference here is just looking at the bridging groups, the linker groups between the quantum dot and the organic conjugated systems. So for the BA, it happens to have a carboxylic group here, so you can see the atoms, carbon, to benzene, and then to a larger PTZ structure. And then the other group, the main difference here is you can see the 2 sulfur atoms in yellow, carbon connect to a nitrogen, and then going to the rest of the organic linker group. And so experimentally, people have been looking at these different types of groups for hole extraction in viewing that can the linker group bound to the organic pieces kind of dictate the speed or success of hole transfer from the quantum dot to their larger organic systems. And so what's kind of been known already is that these BA systems, given that the conjugation doesn't flow continually with the remainder of this organic piece, can slow down hole transfer going from the quantum dot to this piece, whereas the sulfur linker groups, once it was optimized, ended up, well, at least in this version, showing that it was 2 bonds to 2 different cadmium atoms on the surface, whereas having this extra nitrogen can help conjugate the system, allowing for a little bit more of a free hole extraction from the quantum dot. So just kind of as a base, looking at some of the electronic structure of just the small quantum dot itself. A similar feature found in most of these, you're going to see the edge of the valence band, and then just below the conduction band, you're going to see just a little bit of an unoccupied state. And so
which functions, what exactly you're showing to us?
So this was done using VAS, so I mean it's a PBE functional with plane waves for the basis. And so one of the issues that we had talked about before was having a reduced gap in the system itself. So I mean this is just the quantum dot itself. And so looking at comparisons to this first portion of with the carboxylic linker group, so you're going to see some of the same similarities in having a dense valence band edge, and then this small unoccupied orbital at the bottom of the conduction band. And so this energy difference between the edge of the valence band and this unoccupied.
So what is your zero? What is your Fermi energy?
So it'll be at the edge of the valence band. So
the
it
gap
shifted.
is open.
Yeah. So it shifted to align with the edge of the valence band. And
Have
so
you done projected those?
I don't have it in here, but yeah.
Okay.
Yeah, no, I can pull it up, or get that done. So in looking at what they found experimentally, there's a slight difference between having this carboxylic linker and the sulfur linker in how the energy states are gonna shift relative to the conduction or valence band edge. And so they found that that's about an energy close to 1.5 electron volts. So that's what they measured experimentally. And so this energy difference between the edge of the valence band and this first unoccupied state matches that fairly well. The only issue is.
But again, if you need to compare this with your bare quantum dot, right?
Mhm.
So then, what's the band gap of your bare quantum dot?
Well, just of the one that I showed before.
Well, the value looks like it's wider, right? Or maybe you have a different scale. I don't know.
So the scaling is gonna be a little bit different.
So
just
what is the
between
band
these
gap
two.
here?
This one is relatively close to the same. It's like 1.62, I believe. So it's a little bit larger than.
1.6 the band gap.
Well, yeah, for this difference here.
What is the Fermi energy? Is close to the
Well,
occupied
so the way that these are shifted, the Fermi energy is going to be lined up with the edge of the valence band. I mean, I could have it shifted so the Fermi energy is at 0, but that's the way that these ones are lined up.
So you have 1.7 here, and what is the band
And
gap
10,
for the?
10 to 1.
Huh? What do you mean 10 to 1?
Oh, the energy of
The band gap.
So it's
So how much energy?
1.5.
So it's slightly
right around
smaller.
1.5. Yeah, so it's slightly smaller.
So again, and it's two reasons. If you don't have your protector doors, right? So it might be either reconstruction of a surface results on the closing the gap, and maybe you have a trap states on the surface or something, or it's due to the presence of the states on the molecule,
Right.
which kind
Yeah,
of
well-
in the age of your occupied states or maybe unoccupied
Yeah.
states as well.
And I'll show a density of states with both of the organic ligands attached, printed on top of each other, so you'll be able to see the difference at least between the two of those. I didn't include just the bare quantum
But
dot
do you have
in that.
orbitals?
Yeah. Oh,
I mean
the partial
The
charge
clouds.
densities. Yeah.
Ah.
Yeah. So on the next slide. But the other thing I want to talk about is, so this gap here aligns very well with what they measured experimentally for the work function for these extra states coming in from the organic ligands. The only issue is here, what they found with their band gaps was, the valence band that was going to be like almost another 1.2, 1.3 electron volts above that. So their absorption spectra start closer to this 2.8 at this peak here, whereas the absorption spectra for these models now has, primary absorptions, close to this band gap value, so it's going to be greatly redshifted compared to what the experimental values are. So one of the things that I've been trying to use to kind of combat this is use hybrid functionals to see if that'll actually influence the band gap itself. However, those were on the HPC, so.
Also, the good checking point would be if you just calculate TD-DFT, take your structure and calculate TD-DFT.
And just run.
And then, I would say in your case, you have a problem with functionals, right? I mean, you cannot provide the same procedure to the Gaussian
Right.
to compare the correlated versus
Right.
non-correlated band gap. And here you have different functions, so that's why I would say you probably need to run two jobs, TD-DFT with
Yeah.
PBE function and TD-DFT with something hybrid
Yeah.
functions, and then kind of see the effect of the hybrid functional, because the effect might be not just increasing the gap, but also you might have different nature of your orbitals,
Right.
right? And then compare with your non-correlated PBE, right?
Right. Yeah.
So it's actually two jobs for the TD-DFT, and then also analysis of and calculate transition orbitals, and of course HOMA-LUMA for this.
Right. Yep. Yeah. And so now that CCAST has clarified that Gaussian only runs on login2, as long as I can get, so we were having issues submitting jobs on Thunder.
Not now.
Well,
They-
We have
they- Actually, we had a meeting when last week, they're
No.
claiming that everything is fixed.
Gaussian is fine, but we have a problem with bus because
Right.
it's not working on login
Okay,
one.
but Gaussian is not a problem, right?
no, they said they migrated it to the login2. And so,
And logging 2 is now ready with Gaussian and everything, so, yeah.
but yeah. And so after talking with someone on the phone, they explained that to me, so we should be set up to go. So this is what it looks like coming out of VASP, and so that's one of the major issues that I need to clean up, and we'll run TDDFT to do accuracy checks with the Spectra itself. So this is what the band edge orbital distributions will look like. So we did par charge calculations for the HOMO and LUMO of this BA system. And so you can see on the HOMO there's going to be orbital distribution coming up into this carboxylic group and slightly onto some of the rest of the organic piece of the dye, which is what we want. We want this type of pole relaxation to migrate onto the organic pieces so it can be pulled off of the quantum dot, while the LUMO is shown primarily to be localized on the quantum dot itself, allowing for some type of charge separation of the exciton after it's generated. And so looking at just a couple of the other images of these systems, so below the HOMO and the valence band, you see the majority of the partial charge density being localized on the side of the quantum dot and also distributing slightly onto some of those same carboxylic orbitals themselves. So right on that valence band edge, we should have any type of charge relaxation moving towards this part of the system. Whereas when you're looking at the orbitals above the band gap, you see that they're going to still be primarily localized on the quantum dot. So something being excited optically is going to come back down and ideally be, somewhat separated from where the whole localization is taking place. And so in looking at comparing this model with now this PTC model, so there's a couple different things. The first thing is now the valence band edge is shifted just a little bit. Instead of having a clean break at the valence band edge, there's a little bit more density extruding towards the band gap. So the gap is going to be more closed than what it was for the carboxylic linker group. And same issue again. There's still some primary peaks around 2.8 where, the major onset should be, but because of this reduced gap, and also.
Do you have the spectra of the pure quantum dot?
Just the pure quantum dot? Yeah, on my left.
If you put it together on this figure, at
Put
least
it-
we can
well,
see
just do- okay,
which
put all-
peaks
put all three
coincide
together
with
on
the
there.
quantum dot and which don't, right?
Okay.
Since you have a dose to find the spectra is not a problem, and
Right.
you don't need even
Right.
seek out for this.
Yeah. So so this is going to be a little bit of the primary difference, and I do have. I'll just jump to this other slide. I'll just show this. So looking at the density states comparison, so the red is for the sulfur linker groups and the blue is for the carboxylic groups, and so you can kind of see this darker line edge here where the carboxylic density of state drops off with an extended density of states for the sulfur groups.
And what about occupied states? It looks like it's hard to see. I don't know. I hardly see it. So they're kind of in a better agreement with each other, right? Their deviation is less. The unoccupied states.
Yeah. So the unoccupied states, there's just a slight shift.
And even the next ones, right? Looks like they.
Yeah. So the characters can be relatively.
So which means they probably really originate from the quantum dot.
Yep. And so.
No, please.
What, do you think it helps?
I guess you do now.
That's right. Oh yeah, it's better.
Better? Okay.
It's sharper. Okay.
Yeah, so primarily, and ideally that's what we want to see, because if we can have most of the unoccupied orbitals localized on the quantum dot themselves, then we're going to know that any type of excitation is going to try and maintain them on that quantum dot. Whereas the primary difference, like I mentioned with the other DOS, is this extension of the valence band pushing up closer to closing the band gap energy of the system.
But again, the problem. The hybridized. Are they also hybridized? I show in the orbitals for this. Second structure?
I'll go back to that. I just wanted to show this, and then I'll
but kind of thinking about your carboxylic group and kind of hybridization with this molecule, it might be again the artifact of your PBE functional, which is known for kind of over delocalization properties, right? So I would again suggest, especially since VASP is not available for now, we hope it's really have to, we can do it very quickly, but take your structures and calculate on Gaussian, using Gaussian, and you can again compare different functionals, also checking how much your orbitals stay delocalized, or maybe if you go in from PBE to bis-relief or whatever can bis-relief, probably take GGA, hybrid, and then the long range corrected functional, right? So let's say, well, I would say PB, well, it's kind of, if you go with a bis-relief, then you have to be probably whatever the GGA for the bis-relief type analogy. It's B-leap or something, which is not a very, I mean, it's not very common functional because it's not behaves well. So then I probably suggest to go with PBE1, right? And then LCW PBE. Then you go GGA, your GGA PBE, same as in the VASP. Then you go to the hybrid functional PBE1, PBE, well, this is how you put it in Gaussian. And then you go to the long range LCW PBE. And again, wherever, you probably will definitely see the blue shift for your spectra comparing to what you see with PBE functional, and probably even your TD-DFT PBE would be a little bit more blue shift, would be red shifted comparing, I don't know, depends. Because you have here excitonic effects if you compare directly with your PBE results of your VASP calculations, right? But the main point is that for dynamic, because you're preparing your this kind of things for the dynamics mainly, right? And in dynamics, we probably will be restricted. I hope we can do HSE, but there is a good chance that probably would be too much resources can be taken, and we probably have to give up and go back to PBE functional, right? So at least we need to understand how trustable it is, and that all the things which we like qualitatively, we know we are off in the energy range and so on, but if we really see this hybridized picture as you've seen with your PBE functional, right, then it's a good sign, and at least we can trust our VASP calculations when you apply it to the dynamics, right? But for now, it looks like you definitely need to check your methodology and in terms of applicable, trustability for the functional, right? Which we already know probably not very much trustable, but on a qualitative level, again, I said like this hybridization might be also an artifact, and then it really kills the overall approach to the dynamics.
Do you know? I mean, have people run HSE calculations for VASP on Thunder in your group previously?
Yes.
Okay.
Andre suggested, yes.
So Andre runs them.
And I think you will try it, no?
I
Well,
use
when
Someone
I
else.
submit those HSE jobs,
You need your wavecard first generated from PBE. You will probably. Have you been using HSE functional? Or you will not? Just for ground state calculations.
Probably do. HSE? Yes, HEC 06.
Or PBE 0.
HEC 06, there is a template.
yes,
on
yes, I did that.
okay, good, okay. Because so that's why when I'd asked whatever that was the first time, so that's why I put them on HPC, because I was getting error messages. So then I need to talk to you about.
But you need to have your wavecard from your PBE functional, PBE calculations first, right?
Okay. So then, so the other thing that I want to highlight with these then are similarities and differences with some of the orbitals around the band edges compared to the carboxylic linker. So in looking at, this is what I showed you, the HOMO and LUMO on the previous slide, looking at the edge of the valence band, you can see that again, they're going to be more localized around this linker group, but also going a little bit deeper, you see a little bit more localization or delocalization across some of this organic piece. So what they found was this PTC was supposed to be better for this type of whole extraction than the carboxylic linker in the BA group. And so this is what we were expecting to see, a little more delocalization for this series. One of the things that was a little concerning in going up above into the conduction band was, again, it was still localized primarily on the quantum dot themselves for the first few states, but then you get a few random states that have something like this, where now you have this partial charge density delocalized on a large portion of the organic linker and the organic piece itself. And so you might get something like this every once in a while, like every, I don't know, third or fifth state. So how that's going to influence dynamics,
I would
found
say
excitation.
it might be really the functional problem.
Right. And so if that's the case, then yeah, going back, double checking with different types of, well, TDFT and some of the Gaussian hybrid functionals can correct that. Otherwise, you know, if it's something that this comes back being something similar, it'll be interesting to see what happens with some of the coupling values, whether or not you're going to have some type of, you know, larger off-diagonal elements skipping these types of orbitals during
But
relaxation.
am I right? Your HOMA for the carboxylic linkage is more delocalized than the HOMA for this PTC linkage, right?
More
Or they're
delocalized.
kind of the same.
I would agree. With the carboxylic, it was a little bit more delocalized, almost over like a third of
No,
that
I'm
quantum
talking
dot.
about delocalized more to the molecule.
To the quantum dots.
Yeah.
Oh, it's
yeah,
more on a quantum dot,
yeah,
but
yeah,
not
so,
really to the molecule.
right. So this is less delocalized to the molecule than it is for the PTC, which is what they had expected to see.
But in your case, again, you can easily probably put it in a quantitative way, right? I mean, again, it is like you do your TD-DFT calculations just to see the effect of both excitonic effects and the. Actually, you can for the functionals, right? You can do just ground state calculation. You don't need really to do spectra, right?
Right.
You just do ground state calculations again without optimization to be exactly with the same geometry. Just single point calculations with different functionals. Go through these three functionals to see whether you see the same delocalization or not, right? And then on the top you can do TD-DFT for, then you really know what exactly your excitonic effects, whether they really significantly contribute in terms of qualitative behavior. But for the data which you already have, you can easily get it in a quality, right, level. Again, if you recalculate your projected dose, so you know percentage from each orbital, right, and from actually each atomic orbital, whatever it is, contribution from your SD,
Right,
P, and so
equivalent
on,
values,
right?
yeah.
This is what VASP will give you.
Yeah.
And then you just need to integrate over, I would say we don't need SPT
But just
decomposition, you can just integrate over, let's say, your carboxylic group, right? So
Sure.
over those
Just
which
pick that-
contribute
those
from carbon and
atoms.
oxygens. Then maybe your portion for the
larger.
dye, which is exactly the same in both molecules, right? And the portion on the quantum dot. So the portion on the quantum dot for sure is bigger here, you can see it by eye. But the portion on the molecule and the portion on the linkage is probably questionable, right? If you look, because again, you look just on the size of bubbles, the more delocalized, the smaller the bubbles, technically, right? And it looks like your, if you have exactly the same ISO value or something, I would say looks maybe I'm wrong, but yeah, it's hard to say right now. But
Yeah.
maybe you have less contribution on the quantum dot, but you probably have more really to the molecule. So it still will, like, you still hybridized, right? But it's just really going more to the molecule. And I think their explanation, it's really that, well, again, they call it just hybridized states, right, in this description. So not necessarily you really have to be completely hybridized with your quantum dot. You just have some contribution of quantum dot. The question is, maybe this molecule will still have, I don't know, 10% from the molecule and 20% on the linkage, versus the second one gives you only 5% on the molecule and 5% on the linkage, and then whatever, 90, 95, 90, whatever on the quantum dot. And here it's, let's say, 50% on the quantum dot, and then whatever,
Kind of makes it
40,
whatever.
whatever their contribution, right? So that's why I would say it's might be really that you contradicting to what they expecting and what was, you're referring to the paper which you reviewed, which is not published yet, right? So we kind of cannot really cite it right now,
Yeah.
but it probably will appear in a month or so, probably earlier, because it's already months over. So, but we might not really contradict to them, right? So, yeah, in part of quantum dot, you have less, but you might have more contribution really through this linkage and molecule, maybe, I don't know.
Right.
It's hard to see just looking on the graphs, but you can get it from the projected dose.
Yeah, I was gonna say the line clock follows in there, so.
And again, your picture might be completely different if you go to the hybrid function.
Right. And so those are
Question?
So when you have a delocalization in the linkages, does it mean that like band alignment of the ligands and the quantum dot is almost in the same level?
Oh, in terms
Well,
of how,
here you
terms
cannot,
of, yeah.
sorry?
Javid, here you cannot call it quantum dot state or
Or
the die state. It's really hybridized state here, right? Because you have really almost 50, like especially for this orbital, it's really like half and half, half on the quantum dot, half on the.
yeah, that was my curiosity. If it is almost hybridized state, then how it would help you to charge transfer in one directions to other one?
Actually, you have already charge transfer right away. You excite the state and you're already in the charge transfer state.
Okay, then how would it be? I mean, is it more?
It's more efficient. I mean, you definitely expect that this is, well, again, you have, don't forget, if you talk about couplings, right? Then coupling, let's say, from the quantum dot to the die is exactly the same as back. So this hybridized state means you already have it on the die, right? But it's also on the quantum dot. So it means you can, it's really completely the same probability jump to or from, right? So that's why
That's why you need
the
some
question
energy,
would be
energy
next
difference.
step. The question is next step, where this charge spec, can it go somewhere else to be completely separated? Let's say it's a contact with a metallic contact, right? Or maybe another semiconducting material, or if it's electrolytes in a solvent, right?
Okay.
So because if you have another level, like you, again, the idea is, can you go back to those? Or maybe to those where you show in HOMA-LUMA orbitals, HOMA-LUMA or something. Yeah, so by the way, your low state is HOMA-LUMA transition. Do you see it? Is it optically active or not?
So,
Yeah, that sounds.
a lot of the transitions are coming from something below the valence band edge up to one of the first two
So
conduction
Luma.
band edges.
So means your HOMA-LUMA transition is probably not very optically active.
It's
right?
not huge.
But you have, let's say, maybe HOMA -5 or so.
2 Luma and
So
Luma
which
plus
means
1.
probably those states will have more character of the quantum dot, right? But this is for both systems, for independent on a linkage. They all behave pretty much the same.
similar.
Okay.
Yep.
Right.
Yeah, and I mean, with this system, the fact that there's, you know, there a couple states like this close to the valence band edge with a large portion of it delocalized on the organic dyes, those states pop up with a transition to the dyes on, I wouldn't say a frequent basis. You know, the top few go to the Luma or Luma plus 1, then you might have a couple sprinkled in that go to a state like that.
So it means you still, like at the low energy range, you probably expect that you excite the quantum dot, not the die, right? So you can tune excitation just of the quantum
Right.
dot if you go to this low energy, despite this kind of charge transfer states, they're probably not very optically active.
Right.
So you excite the quantum dot, right? And then again, for the whole transfer, it just naturally will end up at Luma, right? Where it's kind of really still have a lot of hybridized character. So which means you probably can easily get to the states, the couplings with other states which come in just from the quantum dot would be strong, right? Because you have a lot of contribution from quantum dot on one hand. But on the other hand, again, the recombination is also enhanced. So like if your electrons still in the system, they might recombine with the state non-radiatively, and you lose your excitation. So it looks like it might have, it's really kind of a both positive and negative effect.
Yeah.
And the question is, so in other words, for recombination, it probably doesn't help to reduce the recombination processes. Means you excite, right? And then you expect that you don't lose this excitation due to the recombination, either radiative or non-radiative.
Okay.
This hybridized state will be make your non-radiative or radiative recombination, electron hole pair recombination, facilitate because of this too much on a quantum dot, right?
You can have very close overlap.
But in terms of whole transfer, it's of course positive effect because it's already on a die, I mean on a molecule. And then really the question is, if you have another level from your, like you need some, how you call it, LEDs, right? Contacts. If you have a level nearby this luma, so but maybe a little bit higher, high if it's a hole. So then if we have this contact nearby, so this state will be moving there, right? And your electron will be moving to another contact, so looks like it's not a problem.
Okay.
Yeah, it provides some additional bias from a whole transport layer, or like the lead contact.
But if we want to use it as a well, again, if you want to use it as a photocatalysis, I'm not sure if this molecule really can be used as a catalysis. Probably not.
Yeah, because I mean, you'd rather see something like these types of delocalizations at the edge of the valence band, because then you're getting a large percentage of that charge out away from the quantum dot, where it's more likely to react with something coming in.
Okay.
So, but again, it could be that the delocalization is either spreading more towards those organic dyes or localizes on the organic dyes, and we'll double check that and see once if that's going to be the case.
Oh, it might be completely the artifact of the functional.
Yeah. Yep.
Yeah, but good question is that like it depends which processes you consider, right? And if you consider it together, then I would say it's really probably a contradictive effect. So the same character increases one processes but decreases the other, and overall you're probably losing your efficiency.
Okay, so for hypothetically, if we say, suppose like we found like HOMO is localized on the die, and like maybe like HOMO -10 or HOMO -12 is localized on the quantum dots, and that state is optically active, suppose like. In that case, it would be more favorable for co-transfer from the quantum dots to the.
Again, the coupling and really how quickly it will be occurring to this state, we don't know. It depends on you need really to calculate it and see, right?
Yeah.
But in terms of if it goes there on this very localized state on a die, right? So this is where you have separation of your charge transfer, because now your electron is just on a quantum dot and your hole is just on a die. So it's a completely charge separated state. Pure charge transfer state, right? So without really hybridization and so on. And in this case, of course, the back recombination from quantum dot to the die, again,
it's
optically,
also less
optically not optically, because you have really very weak coupling between these very charge separated states, right? So in this case, of course, recombination will be not favorable at all, and you help to separate the charges, and this might be really positive.
So that's a
But how quickly it goes, like in terms of does this help charge transfer to a Q? I would say probably you need at least a few hybridized states. The best scenario would be if you have the low state being localized, more localized, and HOMO -1, HOMO whatever is kind of hybridized states. Then they will be coupled strongly with your pure quantum dot where you excite, right? But then due to this hybridization, they will be coupled to this very localized die state. And you probably expect that this scenario will be really facilitating charge transfer and charge separation.
Did anyone ask you today about band bending?
No one has asked me about band bending.
Especially today.
Especially today.
Is there any connection between this effect and your presentation?
I just asked them indirectly, like for band alignment.
So were you asking about band bending?
I mean,
Or
indirectly
you
how
were just
aligned
looking at energy level. Well, okay, so
Maybe you start with explaining what is bending.
So band bending in terms of adding an organic piece to adjust energy levels, or in terms of velocities like of electrons and holes.
Mutual influence of donor and acceptor on their energy alignment that happens upon bringing them into a contact.
So you should get some type of reduction.
Not me.
Well, I mean, so if you're going to have, like something like this, or like an N or a P dopant type energy effect on your band edges, right? Because you're going to get something that's going to reduce your gap slightly, allowing for greater interaction.
You may have already made these calculations. If you take standalone donor and standalone acceptor, like quantum dot and this die, and you compute their band alignments, they can be very favorable for charge transfer in the right direction.
Right.
But upon bringing them into contact,
Right.
their
They're going to
experience change.
lessen the overall effect.
Can you intuitively predict how do they affect each other?
I mean, so you're going to have something very large in the quantum dot themselves, right? Because that's, close to 3 EV.
Mm-hmm.
And, you add something like this and you're going to reduce it somewhere to
But what's the band gap of a pure molecule?
In the paper by Emily, it was negative, so it was just, I believe, just over 3.2, give or take, electron
was
volts for
larger?
just the quantum dot.
Oh, similar to quantum dot band gap?
Yeah, so she had something a little over 3 for her quantum dot, and then the addition of both of these organic linkers like this, were about 1.58 and 1.59, so very, very similar in terms of just separating out the energy states. But putting something like that together, if it's going to hybridize, it's going to lessen the energy for some type of excitation.
But you probably expect that it will be stabilized if they are becoming hybridized. Your charge transfer states probably will stabilize your HOMA, means you're pushing it down.
So what you're telling, the lowest, the ground state may have already some level of charge transfer.
Enough based on its orbitals. It's already like this is your HOMA. It's already charge transfer.
Good.
Did you have a different opinion?
No, I was having no.
Well, you can. I would say I would not call it a band bending, but you can make a parallel between band bending in a semiconducting materials when you band bending usually you apply the voltage actually, right? And you have the band bending due to the charge on the interface.
It's
Plus minus, which
for
kind of
neutral
changing
interfaces of
your
solids.
non-interacting materials. Yeah.
Band bending is typically applied for solids on the range of interface of like hundreds of nanometers. It's of course to.
But again, the idea of your interface.
Shocky barrier, like
Yeah, Sharky barrier.
Myself, no, it's bending. So when you're not really having this
you're
step,
getting something.
but you
that
have
goes-
a smoothing
Right. Yep.
of your step-like function
Yep.
between your bands for two different materials, right? And this, I'll say, bending, this smoothing, right, is a result of the contact and interaction on the contacts, either due to the actual chemical bonds between two semiconductors, which is also possible, defects, chemical bonds, or just accumulate, because usually it's a p-n junction, right? Accumulating of positive charge, negative charge, which also create a huge Coulomb interaction, which also, actually, usually band bending is associated with this p-n junction, which create a strong Coulomb interaction on an edge of your, on an interface, right? Which of course will be changing, or how to say, changing your homolumus, your edges of the valence bands and making this smoothing. So from the point of view of pure solid state theory, right, this is of course not a band bending, but you can make an analogy and kind of band bending if you really want to use the band bending in this case. Because you have these hybridized states which shows that you have very strong interaction, which of course will be changing if you consider just the band gap of the pure molecule versus pure quantum dot, because you expect that they will be kind of smoothing and probably I would say goes, I don't know how exactly, like if you predict it like this, you probably expect that your hybridized states will be stabilizing this HOMA and probably also stabilizes it.
Isn't it you need to levelize, put in the same level of the Fermi level, and then we need to look on the HOMO and LOMO
For
orbital?
non-interacting cases, you mean? When you just look on two non-interacting systems. Yeah, you can do
kind
it,
of
yes.
have a reference point.
Yeah, you can use your Fermi energy as a reference point for this case, or whatever your reference point can be. Right? Yeah, for VASP, I think you can, if you can trust the calculation of Fermi level for the molecule, which actually both are molecules in this case. If you can trust this Fermi level, you can use it as a reference point and see where these levels are for non-interacting systems. But again, I don't think it has been like, they kind of estimated already in this experimental / theoretical papers, right? So this point is probably not very much interesting anymore. But you didn't calculate them separately.
Pardon?
You didn't calculate the molecule separately
Donor and acceptor.
Yeah,
without
they're,
interaction.
yeah, they're in a test file.
So you have your electronic
Just those pieces themselves. Yeah. So I mean that's why I did just that quantum dot itself, and then I have some of the.
But your quantum dot is not exactly like
Well,
this,
it's-
right?
Well, I mean it has the
It has
nine.
one
It
ligand.
has 9 amines compared to the 8 plus the other, so it's kind of a substitution with the small organic pieces.
Do you have
By the way, you have
molecule
a-
itself?
You have a protonated groups.
Yeah.
Carboxylic. It's not really carboxylic. It's carboxylate, or it's a carboxylic group.
It should be. It's a deprotonate carboxylic group.
So it means you're charging your system.
So there's
this calculation is done with a charge.
Yes.
Negative. Both are negatively -1 charge
yeah.
systems.
So first just did a single point calculation. It gives an odd electron count because it's not correctly, the electron isn't accounted for. So then doing optimization with an added electron into the system so that the optimization is done with the correct charge.
I would suggest also would be interesting to see maybe this effect of delocalization might be really due to the charge.
So
I would
you want me to
suggest-
finish optimization without the charge?
No. Without the charge, but then you need to protonate your system, right?
Well, I just yeah.
Otherwise,
I can
it would be dangling bond, which doesn't make really sense to have. It's
Right.
too reactive to be just like this, right? So I would suggest to maybe put the proton not on a linkage group, but on a surface, on a selenium.
just pick a selenium. And put-
Not pick a selenium,
Well,
pick a
but-
selenium nearby, the
Okay.
closest
Right.
to,
So
to your
okay, so
oxygen
I mean,
or
if it
whatever, to your
deprotonates,
sulfur.
it goes on a selenium close.
Yeah, kind of things that like if it was like you start with a protonated because I don't think they have these groups in a like we don't know exactly the mechanism of attachment, the synthesis or whatever, but you can assume that they probably having this linkage group being protonated, right? And then it's going to the deprotonated either in a solution and then coming without the proton,
Yep.
or maybe when it's attaching to the like
It loses
coming
the
approaching
proton.
to the surface,
Yeah.
right? This deprotonation happens and the proton might be kind of kept, or how to say, caught by the selenium. We definitely see it with sulfur. With sulfur it's more pronounced. Sulfur definitely wants to take this hydrogen, but I guess selenium probably weaker, but still possible. And it can be just like a trial model, right? Just to see that in this case you still have exactly the same molecule, deprotonated, right? But you don't need to worry about the charge because your
There's just
proton
another proton
is
there.
just sitting on a selenium,
Okay.
right? Would be interesting to see whether this single proton might change your hybridization. I mean, in terms of band gaps, I hope you will not see a big difference. Although, who knows, maybe the gaps will be increased a little bit because you kind of taken the trap state from selenium. Maybe it even would be increased in the band gap of the quantum dot by itself.
So is it neutral ruthenium dye?
Hmm?
Is it neutral ruthenium dye?
This is not ruthenium dye.
Oh.
There's just organic molecule which is neutral,
Oh, okay.
right? I mean, if there is a protonated carboxylic group, it's neutral.
Yeah.
Or if you take out the linkage, then it's neutral if you put hydrogens there instead of your linkage. And again, for the purpose to compare with a bare dot, right? I mean, bare means without this. It's not bare; it's still covered with these amines and so on. I would suggest maybe the easiest model, which you can directly compare, would be just take out the molecule but leave the linkage group, carboxylate or how do
Or
you
just
call
the
it?
cyanide.
Yeah.
Okay.
Put in. I probably think hydrogen would be good enough. You don't need to put the methyl group on the carbon,
Okay.
right? So
Like,
hydrogen
yeah.
would be good enough. So kind of create this additional ligand, not the dye, but the ligand of different nature, not amines, but something different. And also put the proton nearby, exactly in the same position where you have for your molecule, right? And in this case, it would be really just this. You can compare really linkage group, whether it has contribution or not, because amines don't, but maybe this carboxylic group or whatever, your other group. I hope you should not see it also if you don't have the dye,
Yeah.
but maybe you will see, right? And this also will give you better ideas about how to really trust this delocalization properties, right? Yeah, so try to do neutral system, put in the proton, and also create the reduced model when you just completely disattach the die, right, but leave the linkage group. And again, you can do it with proton and without proton, right? Means again, with charge and without charge. And by the way, it also would be interesting, like if you have just carboxylic group without the die and without proton, zero to negative, with a negative charge, would you see the orbital sitting on these carboxylic groups? Our Gaussian calculations with single carboxylic group or all carboxylic groups do not show localization on a carboxyl. Carboxyl is not really contributing to the HOMA-LUMA gap, same as amides do not, right? But this would be interesting to check. Do you have any other data? Or this is the end of the story?
This is the end of the story for today. I'm getting close to those models you sent me last week from Pone. So even though they were optimized in Gaussian, I'm assuming, they're slowly converging in VASP.
Huh?
They're converging slowly.
Because probably they're too much.
Yeah. So what I've done.
Changed.
Yeah.
Huh?
So there were issues with submitting jobs for a while because it was saying I was denied access to certain queues. So we got that figured out. But then what I had to start doing was going to a low precision, running it, taking that, just using it. Now I'm getting close to the accuracy what I used for this. So hopefully it should be soon that those are done. And then I'll be able to put those in with the N719 die that he had. The other question I was gonna ask was, so he hit the two models that you sent me where one had, two carboxylic attachments, because it was kind of tipped over sideways and grabbing it. The other one was a carboxylic and a sulfur. I mean, I'm running both of them, but
Would be interesting. Well, again, our ground state calculation showing that the two carboxylic groups is more stable, right? So like you're talking about 1 electron volt versus 0.6 electron volt. So significant difference. And this is in a solvent. In a vacuum, you have something 5 versus 2, like even stronger difference, much bigger difference. And solvent doesn't really change the qualitative kind of trends overall, because he was trying different attachments. I just choosing those which are the most stable ones. Okay. In terms of electronic levels, I think those with two, in the vacuum at least, those with two carboxylic groups has the die localized state really kind of in a gap, not in a mid gap, but still close to the edge, but really kind of
it's distinct
as a
enough.
peak, right?
Yeah.
As a very distinct peak. In a case when it's going with sulfur attachment, at least one sulfur attachment, it's also pushing it towards the surface. I mean, towards the bed. So it's not, it's close, but now it's inside, like you don't have a distinct peak anymore. So that's again, we might also, well, we definitely should see this change in electronic structure. I don't know how good it would be reproduced by VASP, but you'll probably expect that the dynamics would be affected as well, and maybe it would be interesting to compare the dynamics, this structure versus that structure.
Okay.
Which we kind of know that probably well, I don't know. Because again, attachments through sulfur increases the hybridized states again. So we see increased in their overall contribution of this. Either, well, again, Gaussian, maybe because of the hybrid functional, doesn't really provide hybridized states, not near the band gap. We see these hybridized states much higher, much or low, or like deeper to the valence in conduction band. Near the band edge, they are pretty much localized either on the die or on the quantum dot. But with sulfur linkage, we see, we call it a surface states, which means that you really have a pushing of the, although it's a quantum dot, but it's pushed towards the side where we have this die attached, right? So it's not really going to the die, but at least it's moving towards this.
So kind of
less
similar. I mean,
similar,
less,
but
less
without
on,
really
less
going
on the
to the
linker,
linkage.
but just
It's,
being on.
yeah, we
that's
don't
it.
have
Okay.
hybridization, but we definitely have this tendency to be localized on a surface where the die is attached, and we call them surface. How to call them? Interface states, not charge transfer, but kind of charge transfer character interface states. Again, due to this sulfur linkage, right? Which again, maybe your couplings will be increased due to this or maybe not, I don't know.
Yeah.
Well, I mean, you can get some predictions, but when you calculate, you will see really is it that.
And then the other thing, I was looking at a couple different attachments
Oh,
with,
but with his structures, I still would probably add the amines there, just to avoid the problem of reviewers saying
well,
that.
consistency throughout. Yeah. So then in that case, I'll put 7 other amines on
Or maybe even less, because with 2 carboxylic groups, you take in 2 cations.
Right. Yeah. So
Or
there's
7.
so
There
there's
should be
8.
9.
Yeah, there should be
Okay,
9.
7.
Yep. Yeah.
Things
Yeah.
like this.
Okay. No, when they're done as they are now, I'll put the amines on and put those in.
Oh, you can add them even before you finish in your optimization.
Yeah, I'll just
I mean,
pull,
at any
I'll
state.
pull whatever the count card is and just add this in. The other thing, so I was looking at attachment with the black dye, both in carboxylic and in some of the cyanate groupings, both, so attaching almost through a cyanate, like coming to the surface. And something that was happening was the sulfur was pulling off of the group and going inside the quantum dot. Like kind of
Oh,
almost
you mean
like,
you're destroying your dye now?
yeah, so the dye kind of breaks away, but the sulfur gets pulled into almost like a surface cavity on the quantum
This is
dot.
cat sulfide or cat selenide? Which one?
Cat selenide.
All your calculations on cat selenide.
These
or
ones are
cat
on
sulfide?
cat selenide. Yep.
The Seeker, he's gone, right?
Yeah.
Yeah.
Unfortunately.
So
So tell him to really switch to cat sulfide.
Oh, okay.
that way they're different.
Huh?
Okay. So yeah, so I don't know if that's just an artifact of the calculation or if you know, I mean, if the
Well,
dye
this-
comes in that direction, it
This
happens
means
to
it's
be
definitely not stable, right?
right. So
Or maybe you have this over strong effect because you don't have solvent.
sure.
Maybe in the presence of solvent, this effect, like it cannot come too
I
close.
actually get that.
Probably, right? And maybe it will be softening and you will not really break your molecule. But as I said, like overall, we didn't. So Gaussian was not given as breaking of the molecule, but when it's really attached directly without carboxylic group attachment, like if you really align it so your carboxylic groups are too far away, because there are 2 in black dye there is 1 isocyanate group, right? Or 2, also 2. Okay, so like you really have to attach it with both. So actually in a solvent, it's just disattaching from the surface. So means it really doesn't want to be on a surface attached through the sulfur. Yeah, I guess you probably can give up with your sulfur structure for your black dye. I wouldn't worry
Oh.
about it.
Okay. Well, because I saw he was.
But you can try different facets. Well, you can try probably different surfaces. And,
Yeah.
I mean, different.
Yeah. I mean, it was just the one that the sulfur actually went in. The carboxylic one is okay. So.
Okay. So you kind of know what to do.
Yep. Yeah, you said I've got a nice
to
list.
do this.
Nice
Yeah,
list.
and hopefully Gaussian can do these calculations much quicker. I mean, optimization with Gaussian should not be as long as with, I mean, again, with VASP you really have to massage it all the time, right? Until it's really converging up to the appropriate level. I hope with, especially, well, in your case, it's like you don't need to optimize it in Gaussian at all, right? So all your Gaussian jobs should be much quicker and you can get results probably in 1 week for your
Yeah.
TD-DFT calculations.
Yeah.
Or for the spectra, if you run TD-DFT, right? Unfortunately, if you really want to see a spectra, not just 2 states, or like not just the beginning of, because go back to your spectra with your VASP. So you can imagine if you calculate, I don't know, probably 50 states, you will be somewhere in this very first small peak, and probably half of your second peak. So you probably need really go to the 100, 150
Right, and account for all
states
possible.
for the TD-DFT, and you might have some. I mean, with new nodes, which we have, take the bigger memory nodes, the new one.
It did
Can
not.
you can
They-
choose. They have.
They, I mean, in login 2, they did not install the big memory yet.
No, not big memory, but the new ones they are bigger memory. Previous memory was what?
Oh,
60
okay.
RAM. I'm
That
talking
was
about RAM.
64, and now
Now
it's
they have 120 or something.
108.
180.
Yeah, 108, not 18.
108.
108, yeah.
Oh, okay, about 100.
So you can request up to 100 GB.
Yeah.
Yeah.
So you probably need a large RAM for because you need really to have your many states, right? And If it doesn't work, you can reduce the number of states.
Yep.
And also there is some tricks. The default, I think, is 200 states in the TDDFT calculations.
You mean TD optimizations? Or
When you say TDDFT and then you say number of states. If you put 1,000, it will not understand you. So I think it has some kind of limits, but you can modify it through the IOP keywords, and this is what you have to dig out in a manual. But I think up to 150 should not be a problem. Start with 150.
State or we don't need, we didn't
Excited
calculate-
states.
No, you need to mention the any state in TDFT always,
Right.
yeah.
But you can, if you mention 1,000, it probably will be giving you error right
Well,
away.
I didn't use that much here. It's a question.
I think you don't need anything if you go up to 200 or something. But then beyond this 200, you probably, well, again, you go to some technical issues anyway. So start with 150. I think Mary was calculating lead selenite, which was like 68 atoms, so 180 or something. And she was able to get up to 150 states for TDDFT calculation, even with old modes. I think your system is about the same size. How many atoms you have?
It ranges 130 to 170.
Yeah,
give
it's
or take.
doable.
So I think you can go up to 150 states, and again, you probably will be not really going up to this energy. You will be lucky if you will be able to reproduce your third peak from your spectrum with 150 states, because majority of them will be probably dark or just very kind of almost degenerate.
Well, I mean, ideally these states aren't going to be there because experimental spectra starts mostly at this peak. So
Well, of course, especially if you use hybrid functions, right? Of course,
So
you
as
will
long
have
as it shifts,
it's shifted
as long
anyway.
as that first
But
onset.
our hope that your qualitative nature, like this 3 peak or how many peaks, they will be just shifted, but you still will see these peaks right there. I don't know. But my point is you probably will not really see such a nice featured peaks. You probably would be lucky if you at least see 2 peaks in your absorption spectrum, because we're really limited in the number of states. I mean, 150 doesn't look very much because they're all pretty much dense.
Yeah.
And they really contribute probably to the first. I'm sorry, you will be lucky if you see 2 first peaks.
Okay.
Any other questions, comments, suggestions, critique? For example, someone doesn't like the colors. No?
Maybe NTOs color, orbital colors.
You don't like yellow or what?
You know, like
Because cadmium atoms color also
just how-
yellow,
how
and
similar
then
they
cube
are?
also yellow, yeah.
yeah, the selenium
Not this
or
one,
gray. I
maybe.
can I can change it to blue. It'll stand out a little bit better. Blue orbitals.
Pure orbitals, okay. So no questions?
No.
So
Is
then
there a big difference in bond difference between the 2 linker groups?
I mean, there's a little bit, but it's not huge.
But when you say bond distance, you mean the cadmium S, cadmium O? What do you mean?
Between the, whatever is bonding from the dye to the surface?
Okay, so from the cadmium to the
But by dye you
versus-
mean,
the
because
linker groups. You're asking between the
Cadmium.
carboxyl.
the size of the linkage
Yeah, the
group.
sulfur or the oxygen bond.
Or the
Like-
bond, okay, because the size of the group is kind of the same, and this was actually the point in this experimental paper, where as I say that the distance, because the question is how far away dye is from a surface, is controlled by the linkage group. So roughly, you really just take a size of your linkage group, and it's roughly very similar.
Oh, so.
But of course, the
bond-
cadmium S, cadmium O bond, I don't know, do you have values?
Well, I mean, I don't have them in front of me, but the cadmium S bond to me has always looked like just a fraction.
You'd expect it to be shorter.
A little bit probably, yeah. But this type of information probably, again, you need a table with gaps, with bond distances, right? For
Yeah.
both, and probably compare your system 1, system 2 with this or that, right?
Yeah.
And if you have charge and not charge systems, also you will have additional columns or additional rows in your table. But this type of information definitely would be good to collect right away, because after another month you really will be will be completely forgetting all these details. Are we ready to upload? Yeah? Do we have anything else for today?
No.
Oh, so we are done.
Meeting is dismissed.
Nice, so we were pretty short this time. Good, so a little bit over an hour. Good work, thanks, and hopefully fruitful not only for John, but the other people also get some ideas, or at least something useful.
Can you put the chapters to right now?
So you have some new data for your nanoplates project? So then maybe we can talk tomorrow.
We can change the table so
Probably
to approach closer.
afternoon as well. So because we have a meeting at 10, so I hope probably will be okay to come around 12. So we might take this 2 hours. Then I go to the meeting, take a break, and then we start with Hank. Will work?
That's cool.
So you have all your data
Yeah, I just need to put in the
put it
pages
in a
and
more systematic way, so we will go. So you have your quantum data for the dynamics now?
dynamics and the nanoplates
I
one.
mean, quantum dot without ligands,
Without
quantum dot
ligands.
with ligands.
With ligands, I stuck in the middle because
After
of
talking to
clustering.
the
I
adversary,
couldn't
the
able
Also,
to
we
run
still
it.
don't have
He's
it,
not
but
interested
at least
in
maybe
that.
those or something, right? I mean, you
No,
can have
my-
some preliminary
Oh,
data.
yeah, I didn't plot those one because I
He
was
submitted
Well,
doing
take a
that
look
step
on
two.
the-
Yeah, I can
Are
do
you
that.
are you
quickly.
on a second step too?
Yes, step two.
So you can do it again snapshots for the doors,
Okay.
and then maybe average, like let's say you take 100 femtosecond to 200, oh whatever you,
I did up to 650 is done.
which is good. So take really snapshots, probably 10 of snapshots from this range, and take the same snapshots for your bare dot,
Okay.
So
right?
I
And
sent you
then
a version
average,
of
I
a
mean,
web code
plot the
for
doors
RRR
over these
to
snapshots, the
calculate
average one for both of the structures, put it together, and this would be kind of good
Okay.
idea to see how much is it different.
For quantum dots with the ligands, I'm just running the different geometry because I'm not sure about the geometry how
You
it.
mean the ligand? You
Yeah.
mean geometry on the different faces, or
Not
what do you
different
mean?
pages in the because I optimized their
So
geometry.
you use
putting
them
the-
exactly in the same, which I don't remember. Wherever you position on the facets for your nanoplate, right? You put the ligands exactly in the same position.
Even if he's not.
No, in the ligand because in the nanoplates ligand was in the planar, in the linear molecules. But
And then what?
in a nanoplates,
Proceedings.
lead clot is linear, but in the lead clot is not a linear in the ligand in the quantum dots.
But doesn't matter. My point is that you have to place them exactly in the same LEDs and exactly in the same spot, whereas they're sitting
Same as 1 and 2.
in your nanoplate,
First I
which
tried
is
to-
1, 1, 0, I guess.
Oh
right?
yeah, phase is same.
Ah, okay.
Okay. Oh, I thought that is a position. No, phase is same.
No. The place in the sense of the surface.
Yeah, surface is same. Yes.
Okay.
So
The number of ligands
in
is
the
the
number
same.
of ligands, yes.
Okay, good. And then you're saying it just really alignment
And
of
the
these
positions here. So I'm just trying to optimize in the different initial position with that one to see how it's changed because
So is it really changing due to the like if you start with this
it's
versus
actually
that?
it's actually very
The dynamics
it's
is a
actually very
difference?
selective to initial position with the layer alignment because the one layer is supposed like selenium, another one is lead in the surface atoms. So
Just see.
based on the positions,
See,
it can
when you
bend is same,
but do not
but
comment much on
atom has a tendency to flip like this one. Yeah.
Try to do it.
Change the
Or-
angle,
Yeah,
right?
change the angle.
Okay.
So that's why it's giving us a different. In some molecules, is forming a chloride bond with the lead. In that case, other chloride is little other lead is
So I mean,
popping
what I
up,
have done
popping up little
was
bit.
in the words.
So it's
I wrote
overall
a
it's
web
giving a
to
different
take all the
geometry.
indirect
Okay.
transitions.
But I mean, like when you run dynamics, probably you should see both
Yeah,
structures
there's
at the
a
same
label
time,
that's
like
right.
in different snapshots.
So now
And
it's
for dynamics, this probably
tensor
should not be
that
so.
has
But yeah,
all of these
let's see how much
components
it
taken
will be
into
changed due to
Oh,
the
no,
initial
no.
conditions through the
And then we
dynamics.
just need
Okay,
to
good.
funnel them
So
through.
let's talk. Then I think we probably will be
Yeah,
fine to
tensor
1 hour
elements.
probably. But
So now
Okay.
let's put it
it's-
at
once
noon
we're
and see
all
how
in
long
the
it
same boat,
takes.
that's where.
so how was your exam?
I've written that.
Did you get your grade already, or it will be postponed?
I mean, I would assume.
I answered all their questions.
Continue
But did they
this
give you
one.
like say good? No.
Maybe they can. Maybe they need to.
I think-
report
Oh,
it.
it's already on the system.
Following,
No,
just
you
gonna
don't know
add
your grade
a
yet.
couple loops.
It was like a defense. Right?
It's something.
But is it for the grade or just
I mean,
pass
it
no
is
pass?
I feel like you have to do really, really bad to not pass.
I want-
though.
But is it a grade or pass no pass?
Let's do more.
satisfactory or
Because I mean,
I don't actually know.
you still probably have a way, you probably will not get people getting COD if they come and do it, right? But you probably still will have a variation between A and B
Yeah,
for some cases.
I'm not sure. I don't know. I didn't actually check.
Okay.
I don't really care.
But was it good?
I guess this
Did you
one's
have a lot of
supposed to be.
questions?
I had some. I wish there were more. They kind of. We had a midterm presentation, so similar but like half as long. And they asked me a lot of questions I couldn't answer. And I came now with ready to
Prepared.
answer all those questions and more. And they barely asked me any
It's a lot.
questions.
Because they kind of
Maybe
realize,
they got it. You are well prepared.
they kind of realize that you're already prepared.
Well, that makes me sad. I was ready.
I guess that they got it. Don't worry, they got it.
What I suggest.
It was good, right?
abandon our previous-
So I don't know when you, was your last exam or you still have exams?
I have a big project due in my education class on Thursday, and I have a final in math methods, physics
to
math
play
methods
this
on Thursday.
super RRR.
Thursday?
So Thursday
Super
at
energy
like
pop.
6:00 p.m. I am done.
And feed them
So do you go home right away?
so that we use all
Oh,
put in the
then
same
I'll
format as
do
we did
research.
before.
Start right away.
And so
on
that-
So you're not going home at least for
First
the
I've actually taken
weekend,
all of these couplings,
Friday and
get them
weekend?
into
Well, I have this
the
thing on
RRR.
Saturday.
I was still
that I
planning
have
on
to go to
migrating
the
them
graduation
into
thing.
the old dynamics.
Oh,
That
official
way we
graduation
don't-
this
that way it's
Saturday.
not all blocked.
So your parents coming?
So that
Oh, nice.
I don't want to go to this, but my parents says I have
No,
to.
you have to. At least, yeah, it happens probably once. I don't know. Graduation for the graduate school is not as official, I think, as a BS.
kids
At least not at this university. And even at the other universities, I think people usually not paying so much attention for the PhD graduation rather than BS graduation. So think about it as just a thing which you will have once per equal life.
List of traditions, or if it is resolved to one list of energies traditions.
Yeah, I hope I can be much less spread out, concentrate on like 2 or 3 things instead of like 18. Sleep.
That's happening me now. Yeah.
Yeah, you're spread all over the place.
You also don't have enough sleep?
No, not sleep. I mean, they're spreading like everyone, like talking with the Sika, Daniels, then looking on one computer is having a problem.
Oh, and we still didn't order the discs, right? Can
And
you
I
go
didn't
with
take
this?
out, I got
I
that
don't remember
because,
what exactly was it like. Whatever, choose something. It's too much for me now. Choose the best ones, right? Choose the best one and send it to Connie.
But one thing you can help, I mean, how much will you be budget things
So,
Oh,
how much you can spend on that?
And what again was your? I should find
Can you
it.
spend like 1,200?
No, we need how many? We need 3 for sure. We need 3 for the.
Two.
For the.
It is based on
Yeah, for the NAS.
Yes.
But right now
Then we
already
need
have a
2 for
data
the NAS,
from our
2, not
calculator.
3?
Well, we
not
can
3, because it's a 12
do
pay.
it ourselves, but that's divide and conquer for better efficiency that we have companies.
If you want to spend money from the project, like you need to spend immediately, this kind of things, I would suggest you
Direct
just buy one
transitions.
extra in the future if anything happen.
Right now there is a question how to run actual dynamics.
No, we don't because I.
Oh, okay.
I probably might. But right now, we're sending the extension and waiting for their solution. If they will not allow us to extend our money for next year, then our DOE money have to be spent by 1st of July.
So we have a 1.5 month, okay.
And then,
Before this
well,
step,
I just put
which
my
is getting
salary
the future.
and then no problems to spend them. I mean, full salary, like for the entire week rather than just one, I mean, entire month rather than 1 week.
And working days you cannot migrate occupation from one key point to another. Therefore, it was big smaller size matrices.
Do you remember the date
Now
when
we
you?
want to merge them together
Oh,
and allow them to move wherever they like. And
I mean, if you
We need to
let me know that how
use
much we can spend, then I can get something in among
and
this.
in addition
amount.
to applying the school engineering data,
But you gave some estimations there.
Mhm.
how we wrap it up with equations with the period and methodology section.
When it was March or April?
It's in April 12.
So will be ready. Not in
19, 18,
maybe in
17,
3
16, 16, 16.
when, maybe even in a month. Not very well.
Oh,
You better
okay,
start
okay.
communicating with them. For
So,
example, like,
you send me this
Doji,
one.
Maybe in a week or two later on the results with this method. Because it's more intellectual.
So what's the difference between this
So if we
this and
bought,
that? I'm kind of lost already.
oh, that's actually
running this
different
method
model.
code until, as soon as we agree.
First thing is for NAS, if we buy,
You mean the first column? Oh, the first.
no, this one is for additional one. First thing is NAS I mentioned here.
The first
If we buy these models, this $190 for each, in the two, in total like $380.
So I have
Oh.
Yeah, that's
section
for,
that I had written.
and in this
So
case,
this is looks like we don't have
Conference
like
files
we
from
kind of
different
don't have
Android
any choice.
transitions.
yeah,
You're
so we
going
need to
choose
buy
it.
this one.
Okay.
them all into.
Because there's only
Then
this
Then what's the
model.
difference between this and that?
I just give you more some
So
options
I
there.
had
If you buy the 12 terabytes one, it's $450.
How many of them we need? 3?
It is up to us. But this one, no,
But we
this
have
is
space.
this is not for NAS. This is for the photo.
But we have how much space we have? Just for
They
one?
if they have, I guess,
logic
they have a 3 slot
In addition to what we have, or the idea is to substitute?
to substitute.
Okay.
Yeah,
So, but again, we don't want to substitute all of them, or we want to substitute all of
one
them.
or two.
So we want to have them, at least one with operation
Yeah.
system overall, I don't know.
Photon. I mean,
How many actually we have?
we have now three SQS directory. There's the old one.
But one is used for operation system and everything, right? Probably you don't want to.
No, I'm not
So
not
it's
that one.
not-
I'm talking about only extra.
Oh, extra. So we have 3 extra.
extra. Yeah.
Okay. Which
That
actually
could be
we
replaceable,
can
yeah.
replace all 3 of them if you want.
Yeah, if you want.
And you're suggesting so we go from.
We can go like 8
But I
terabytes.
still don't understand.
If
So
you have all
if I
the
go
files
here, it's
on
8,
your
6, and 4, right?
Data files.
Mm-hmm.
And here's 4,
Just
6, and
just in
8. What's
case
the
if
This
difference?
actually different
Just
model,
to
so
spawn.
the updated one is.
So that
Which
you
one is better?
I guess this second one is better.
Stay
These are
alive.
the one or a code up flow.
well, I have
Oh, you know it's better.
Because in the
I have
website,
a
I
couple
mean,
of
as
files that
they're
we used for
doing, and I
But the
also read some
reviews?
reviews. Yeah,
direct transitions.
Okay.
is it more faster? It's
But then I
faster.
don't understand.
Well,
You have
I should have some.
you have 4 terabyte for this price and for that price.
That's a different company.
Ah,
Like this
You
is
mean-
from Amazon. This is from one.
where
other.
you order them.
Yeah,
So
order them, yeah.
obviously we want the
Mhm.
cheaper one. But the question is, can we use the same link? Like because we probably will go with a single order, right?
Mhm.
Rather than 5 for each drive.
Okay.
So
Yeah.
it means we need to order
Yeah,
them
we can do that one
all
and
of them
dealer from
at
the
the
second.
same
Yeah.
at the,
So I
from the
have-
same, let's say
Mhm.
Amazon or
Direct
wherever we go,
for
right?
Mhm.
111.
Okay. So
If we go 8 terabytes, if we bought the 2, it would be around like 550.
mhm.
And they have a 400.
Well, I'm
Into
trying to
like
I'm trying to find it
900
first.
one.
Maybe this isn't the right file. But then yes, I would like to
$950
share.
in total.
And then, when I need to present the methodology, try to do the code or.
After you, well,
Or we can go with
you will be the main judge.
so we are almost 1 to 2, right?
If something is not logical, choose
So 4 terabytes. For 4 terabytes, we need to pay almost twice
I'm gonna have to look
on the
over it.
4
But I
terabyte.
know I had something that.
So I guess.
I mean, they
yeah,
roughly
right.
speaking have
Mhm.
2, but I'm kind of thinking that if we go with 3, then we can go 1 is 12 and 2 is 8.
Eight, yeah.
So we will be, are we still, are we above 1,000
just
or
share
we kind of in the
as
1,000?
much as you can and probably.
No, then we need,
Probably
they have a
answer
400 more
questions
for
and
2 additional.
maybe
We need to
try
consider
make
this
it,
400 too.
comments.
Oh, no, I'm
also
in addition to this.
Oh,
I
okay.
understand.
Once I find that last
300,
file, I'll send it to
600,
you.
600, 1000, 1050, yeah. $50 kind of.
Oh, you mean
Two
together
eight-
with
this-
this,
yeah,
yeah,
two-
so it's around
280,
1,000.
Anything else
280 times 2
seems not clear
plus
or
450
changing.
plus 400.
Once I find it, I'll make sure
So
that it's.
with the NAS too, I mean for
it is what it
NAS,
should be.
in total it would be like 1400.
Try to make sure it
So
migrates.
if we go 8 and
Puts the right
12,
files out that we can migrate.
Yeah, as you said, I mean the 2, 8, 112.
Just one.
Oh,
This
one.
one, that.
And it would be like around 1100 now.
So
Oh, it's better than to take 8 and 8 rather than 8 and 12. Well,
I guess so, yeah.
So
Maybe it
just
will be easy to
16 versus
manage.
20. So again, the idea is probably it's better
Yeah,
to,
I mean,
to use the
hopefully,
same
well,
size.
by the time it's sent
Same
to
size,
you,
same length,
it
yeah.
should work for
Same
me,
parameters.
but it needs to work for other people too. And once it gets
So
migrated.
280.
Then probably we can go 3 with 8, right?
Okay.
Plus
We will be
400 on the other side. So it will be around 1250.
yeah. So let's go with 3 by 8, right?
Mhm.
So means 3 times 2,
But you
80. What is it?
typically
Yes.
groupings online.
Is around 800. 280
Yeah, I mean I know
times
it's around, but
840.
yeah. And then with this around 400, so I think we still will be a little bit above 1,000, so not a big deal. So yeah, so let's go 3 by 8 and 2 whatever we have with 3
2 3 gigabytes.
2 3 yeah.
It travels right.
So then hopefully you can order these guys and that guys from the same
Okay, I look for that one.
link.
Okay.
If not, we can of course make like 2 orders instead of 1.
Okay.
But probably again, if the price would be very different for what you found, if you check the same kind of. And this one you really need this specific whatever your value.
And
it's not
this,
so
yeah,
much
they
sensitive.
told me that you can take any brand, but size of should be same.
Right, but
So
any
so
brand.
this
Any
one's
brand.
fine.
But
This is-
but
I'll send it to
I
you.
would prefer the same model, same prefer
It's
because
already
last
there.
time this
Yeah, I also agree.
yeah.
So again, check if you can get the same model from the same
It's always a
link
combination
and this
of
one
two
or
key
whatever
points.
the link they prefer. I mean, you can order these guys. You
Indexing
can
them
use the
as
same for this
K.1 and
8 terabyte
K.2,
guys, and the price is not very
so
different.
that
I mean,
it's kind of
if it's
like
285,
nested
probably not a big
so
deal.
that
Okay.
if they have to be the
times
same,
3,
it's
you have already saved
$340.
Yeah, so
transitions,
it's
so
probably
it puts it out.
Okay.
paying for nothing.
So this is
Probably
all
better saving,
exactly
right?
what it was in
So
the
decide
code that
on
we
it by
already
yourself and then
had.
send the email to
Basically, what I
Cory,
ended up
Cory,
doing was,
Cory, whatever she is.
adding
It's a
in
C to me, so I
what
know.
happens if,
And then I will
so-
confirm the
so I commented here, so
the
this is
grant.
for either.
Should I let them know before ordering or?
before ordering. So just say like we're going to do the order. Here is our kind of prepare here, so she knows
She knows
that
what
this
we
will
want.
come, and then I will immediately confirm her saying, please charge
So-
this. She probably will email to me and say,
Yeah, so then
what
this is
what
the
account
point
should I
where
charge, and then
this is
I will
built
let
into
her
the
know and
transition, so now
say,
you no longer
order,
have to be-
please
that you can
use
send
this
to each other.
use this account, please order,
Because
and then she
initially
will order it for
I
us.
had been trying a couple things and it was failing.
But yeah, I guess
This
the
one-
decision was done.
So
Okay, so for the VASP,
but basically it's gonna be doing the same
For the,
thing.
I'm just wondering one, just a week or 10 days ago, Nick emailed me, he wants like
Once we get
some input file for run trial
these
the
lines
bus
down
in
here,
the login
it's
queue.
calculating
That time I thought that they got the source code and everything,
for
but
those two specific key points.
is it possible to get the source code by them without
This are
you?
our file. And so
But
now.
I'm just
Oh,
wondering
well-
why he asked for that.
okay,
trial.
no.
For one single momentum point, now
I
you have.
still
multiple
forgot
indices building into
to ask.
this really large
Let me
matrix.
ask Andre.
So you can
He's
choose,
probably
so
will be not available.
Yeah, after that I didn't talk with you, maybe I thought that they got the source code, maybe they are working
No,
on
they're
it
waiting
now.
for us.
But
What we can do, let's say, Dmitry doesn't have the license
two-dimensional.
under the
And
CCAS.
I mean,
on the
we could pull the
So-
information out of this and build them into.
Theoretically possible that CCAS
formally two-dimensional.
he's paying from his money, but CCAS is buying this
But,
license for him
the indices
and
will
kind of
be,
put the PI
tricky
on
indices
this
that will
license,
include both
CCAS
number
S,
of band
as a
indices
PI.
and index
Okay.
of key point.
which means for Dmitry that he's losing one
But
part of
it is
his group people.
for something
Which is
that
of course not a good
if one has a lot of paperwork and print.
But on the other hand, then he will be
Two-dimensional
not
matrix.
worrying about, like, they will be able then
So
to do
right now
it
you-
and
Because
they
this,
will
Right now
yeah,
you-
this stores it all
for-
into one.
they
Right now you have four indices.
have it, exactly.
But you can
the
add
access
maybe
to all
one
the
more
source
cycle
code
where you
and
convert
everything.
4 indices into 2 indices.
But I think this
Right.
type of
Yeah,
thing
so
has
I mean,
been done with
indices
Andre's
are
license.
I, J,
Because I think
T, K.
Andre's license was
you
And
under
now you
the
can
C
have
cast.
super index
Oh, okay.
And in this case,
like IK,
someone
which equals
should be the PI and they should be available to get this license.
But is it more important like under the seekers because the bus
I-
license is kind of depends on how many
Plus
users, is not a site license.
number of key points
So what's the
multiplied by
question?
K.
So
So it's same
if
like
they have a source
digits.
code and if you buy the license from the, if you pay money to bus
So it
people,
will be,
can you use the
non-ambiguous
from here or you need
counting
to
of
talk with together again?
like if you
Because
have
is a number
times
is just is a, you need to pay
four
per
digits
user,
and 2
right?
key points.
Yes.
So
you
if they
can
have a
have it
source code
as either 2
and then if you have a,
or
I mean Ccast,
4
Okay.
and then if you pay
And
the you
code.
money to the bus license, then can you immediately start using the here?
Yes.
This 1 and 2.
Right,
And
immediately
three and
as
four
soon
will
as-
be
As soon as
They
you have
give you
a
access to the
access
source
to
code.
the-
Actually,
next two.
you pay,
So we need to design.
but there was a
It's very childish,
But-
very simple that we need to carefully
Not that
design this
simple.
procedure.
Okay.
so you
Yeah.
have
Converting.
because this
Two
company
indices
is
into
not
one super index.
associated with American company. It's Vienna.
Vienna
Making the
So
same
it's
for energies as well.
Austria.
University of Vienna, Austria.
So
yeah.
I mean,
So
the
two-
company by itself is
in
registered in Austria.
two-dimensional format.
Yeah.
So,
So that
which
we
is
do
kind
not
of
change the
international
procedure for
something.
electronic.
So the university goes through the special agreement. Let's say if something is well, the problem is that if something happens, let's say the company decides that you're not using their license in agreement,
Mm-hmm.
then you have. I mean, they will sue the
Reread this.
PI, right? And the listening will be in the court of Austria,
Okay.
which of course NDSU, but everything what we do
Yeah,
on a
in the
campus
US
is supposed
like
to
The line where
be
you saved it.
the property or whatever of
Yeah, yeah.
NDSU.
There's like an.
So and this
Yes.
agreement in the
Like I said,
license
this was, I mean, this
was
is
a
like
big
the
issue
law.
when I was
But
getting
you can share this, let
And
me know, but for
I was able
information
to get it through
purpose
only because
Yeah.
of I think it was
you
because
may
of
get
Martin was
inspiration
helping
and
me
modify yourself and then
Mm.
through the administration
You can
level
compete, but
when, because
right now
Martin Asowski is a previous director.
John
Mhm.
tried
So
to
he just
compare
came,
to
he was
way that
enthusiastic,
can run
and
then
like it's the first thing I came to him saying, oh, we have a problem.
modify
So somehow it was solved.
test.
Okay.
But then when Dmitry came in
I
2015,
wouldn't mind
so
your idea, but
somehow he didn't want to go through this once again. Or maybe it was not, maybe it was even
having
before,
this,
yeah, no, I got this even before he
dimension
came. So
analysis.
someone was helping me.
additional
Someone from
features.
Ccast under the,
We have
before they actually get this new director.
procedures that
I think it was under IT people, and it was IT people who were helping me with this license.
Oh.
we just
Probably it
blindly
was
utilize
Mark
this procedure.
Wollman,
If you're doing
the
this
director of the IT
for
IT
individuals,
group or something. So anyway,
to
someone from IT
redesign
people were helping me
whole
with that.
procedure of the
Because I
organization.
tried it by myself, I immediately got a huge number of emails from administration saying that they cannot sign the license because of this, that, and that. So somehow it was solved. When Vidi came in 2015, so because again he was trying to get over this problem, but it was pretty much the same story. And I think Asowski was not really in the
Yeah,
mood
once
to
I get
help
it.
him.
Once I
We
read through
tried
this
to
again,
get the license here.
In 2015, it was the first trial, and somehow
how it's
it
all
was
indexed
not
out.
very
Because
simple.
I
So
think
that's why he
what
kind
I
of
would
stopped.
do is take this.
But again, if Ccast will be really as an owner of the
I
group,
have a
right, the
very
PI of the
similar
group,
idea.
they of
as
course
a
have
class
to
person.
deal with all this administrative
Maybe we'll
steps and
design
so on.
something better.
How quick it would be, I don't know.
Yeah.
In my case, it took me
Seems like
several
it's a
months.
lengthy process, yeah.
In my case, it took me several months to get it through.
Like
So
you have
I don't
several
know how good they can
cycles
go
inside
through this
each other.
administration
No.
thing.
And the very inside
But probably it would be much easier than
You can-
really doing it by ours.
use
And
the-
this director is very active, I guess. I mean, he
But
is
this
like.
is exactly the
contact
point that
was
we have
contact.
already license from Andre, which
and
should
then
be
use it
associated with the
as
Ccast.
index.
This is what let me just
And then
quickly ask
you
you.
convert your multi-dimensional
On this subject, I have a question. Why
So
can't
we
I
use
know?
progression. This is not the best. One can do something more.
So, I mean, logging one VASP works, right?
Yeah,
Why
but,
can't,
but problem is they disable all queue. Only short queue and medium queue is available now.
for VASP,
For, I mean for overall, not for
in login
in
one?
login one.
So
Problem is I need the long queue once
you
at
try
least
or
once.
you
I haven't-
entertaining yourself with
version of
the
VASP.
Hello?
to log
No,
into?
I haven't yet.
Why do they need the
No,
new
they
one?
want the new updated one.
Yeah, but can't
If
they
they install this one, oh, they have another issue, then you
It's
can,
either
they
either
bought for
they
one
have
one
Maybe
license
it's done.
or one system.
У меня вопрос про WASP license, который
They must have some licensing.
ну, если не сегодня, то хотя бы
You
завтра.
cannot use the one license in all machines.
But you can uninstall it if you want, and reinstall it on the other. If, I mean, you know, you guys are using.
Do you have enough confidence on this guy? And okay, they try to solve that one actually. They create a default queue for us only. We can submit the longer jobs, and they didn't let them know that. They just shut down the and disable the all queue. I thought that there's maybe something problem, and maybe it will enable after 1 or 2 days they will fix them. I wait whole weekend, but it didn't say anything happen. Then I emailed them. Then they said that, oh, we create a default queue. You can submit your long queue job in default as a default queue.
I hope so.
Okay, then I thought that I was happy. Then I submitted
Whoa.
default queue.
Once
It accepts my job,
it doesn't submit, doesn't show up in the show queue.
Yeah. and then they said that I emailed CZ again. Then I wait 2 days. I thought that it didn't get queue.
You email Sigi, not Nick.
CZ, I emailed CZ and mentioned the CZ. I
Because I
supported
promised
the
that
support, and
it
then
will be submitted.
he did that. He told me that because my first job was 600 hours, all other job was 168 hours. 168 hours is enough time for logging log
It
queue.
will not happen for us.
6 hours is for condo times. So he saw my 60-hour jobs, and then he said that, oh, mistakenly I put the times in like 160-hour limitation in the default. That's why your job is not running. He changed the default time to 600 hours.
No, just yeah.
He didn't notice that my 168-hour job still is not running.
USD.
So then I figured out this create a queue, but they did not assign any nodes for that queue. So they have no 0 nodes for the default queue.
USD HPC is not very powerful.
Then I emailed them today morning again, show them this problem. CZ still didn't reply. He was replying immediately before that. Because he was in online, he's looking on my problem. After showing this problem, he didn't reply to anything
A
yet.
couple of things I tried, I gotta figure
That
out.
means he got the problem, but he has
At
no
USD,
solution
it was
for
like-
that.
I don't know if it was John.
But
So-
I mean, if there is a solution, then
I think it was John.
So if you, as you said,
But
if
it was
you
trying to think
uninstall
of
from
well,
this
I
system
was
and
thinking
install
how
the
much my password.
bus
When-
on
when
another
you
system,
trying to use
if
this,
somehow it didn't, it won't work,
it accepts the password.
then you're
And
not
it says-
busting anywhere.
And I get to directory.
But I mean, it's their job to make it work, right?
Sometimes
I
it seems
don't
like
like
they are working
If
on
you-
trial and error version.
In worst case scenario, it can happen if
But
the-
now they're trying to be fancy,
just
like making
failure
specific
or
queues for
it doesn't
specific
allow
people
us.
to run for specific lengths of time on login one. Wouldn't it be easier just to uninstall and just clean reinstall on the new
Because,
system?
I guess it's a
more
big deal for
information
installing
about
old systems.
user accounts and
They have a
passwords
non scratch
on one disk
memory,
and,
PBS,
user data
everything here.
are on-
And they are using the
typically
PBS Pro
that's
on the other
the
one,
one
the
is usually-
58 version.
accounts
So
is
they
very
have all
small,
those
big
issues
disk,
too, yeah.
and there's data is large and not secure.
Once I suggested CZ to use the slab instead of
Me too.
PBS. Slab user is a more
Okay, so
expensive one. Something like NARS and all other cluster they use the slab. But they went to the field. PBS is
And if we can get it to work. Work efficiently.
we're done.
Good. So then, I don't know, I would like you to talk with Rasika. Do you know when is he going to come tomorrow? He's coming every
Tomorrow
day?
morning, he'll come tomorrow
What
morning.
times do you usually come in?
Pretty early, right? About 9 or
About 10?
10?
9 or 10? Okay, that's fine.
So I-
yeah.
Try to come probably by 11 or something.
Oh, I was planning on being here by 8, but that's.
I'll be here definitely by 9.